Oceans behave a bit more like streams do when we talk about how they can handle pollution. But once again, it's the quantity of pollution that's in there. If the quantity isn't very high, then the area can recover. If it's too high, then it can't. So the coastal waters are a concern because that's where a lot of our industry is at. A lot of people live there. And we also tend to, because it's shallower along the coastal regions, that's where a lot of our shellfish and things like that tend to live. And so we're using it for economic reasons as well. It's also where a lot of our oil reserves are at. So there's a lot of things that happen close by. An estuary is a place where the water is sometimes freshwater and sometimes saltwater. So during high tide, the saltwater comes into the area and it has a more saltwater quality to it. And during low tide, as runoff happens, because it's where a river comes down into the ocean, and there's usually like a protected bay area around it or something like that. So as the water is coming downstream, then during low tide, it tends to flush out some of that salt water, and it tends to have a much more freshwater characteristics to it. So the organisms that live in estuaries are uniquely adapted to this changing environment, to being sometimes in the water, sometimes out of the water, having more salt content, having less salt content. So it's a very delicate area. And a lot of these estuaries are very close to where a lot of people settled, where there's a lot of industry and things like that. Make sure all of that fit on my screen. So when you're looking at an estuary, there's lots of different reasons why contaminants, and just in coastal areas in general, why contaminants can get into the ocean and what can happen with those. So when you look at, here's runoff coming from industry, and the same kind of things that we talked about that happen in streams and lakes happen here in oceans. It's going to impact the critters that live along the bottom in particular, because a lot of that stuff is going to be heavier than the water, and it's going to be either a toxin or it's going to be it's going to cause eutrophication. It can cause, once again, these oxygen depleted zones, because some of these areas, so the cultural eutrophication can increase rapidly the amount of nutrients, which causes an algal bloom. And in the ocean, sometimes those are called red tides, because the bacteria and stuff that's growing and the algae that's growing is red. And so it shows up that way. We have the runoff that comes from agricultural regions, whether that's from fields or from feedlots and that kind of thing. We have the same kind of sedimentation that happens, not just from logging areas, but also from construction, and anytime that we churn up the soil and cause some of that to run off. So we have a lot of the same issues that we have with lakes and rivers in the ocean. It's just that the coastlines are significantly larger than our freshwater areas are. Here's what an algal bloom can look like, just to give you a little perspective. This is a boat down here. So it can happen over very large areas. The Chesapeake Bay was one of the case studies that you should read about in your textbook. And the Chesapeake Bay for us was an area, if you look at the map, obviously this is an area where a lot of our primary settlement happened in the United States. So there's been people here for a very long time, and those people, as we went through the Industrial Revolution and all these little rivers and things like that, first we started to put water mills on there. So the old-fashioned, where the water would go through the mill and it would turn the stone and grind the wheat into flour and stuff like that. And then we started using our turbines, and so now the water is going through the turbine and spinning to make electricity. It was also an easy way to get rid of waste, so they would just dump their waste directly into the water. And all these areas, all of this green area feeds right down into the Chesapeake Bay. And so any pollution that happens in any of these areas comes down in here. The other thing to keep in mind is that this also represents the Appalachian Mountains. And so basically all of this, starting from over here, is like downhill, coming down, because you're coming down out of the Appalachian Mountains. And in the Appalachian Mountains, one of the things that we do, particularly in the Virginias and coming up into Pennsylvania, is we mine coal. And so we have not only the regular things from industry and from people's actions, but we also have the fallout from coal mining as well. When we look at the ocean oil pollution, most of it's coming from what we do on land. So it's coming from oil that spills on the road, that kind of thing that runs off and into the storm drains that ends up into our waterways and into the ocean. We do get some that are from accidents like what happened in the Gulf, or where the oil well itself exploded, and we had a great deal of oil that went into the ocean that way, and then also from oil tankers. So when they spill, you're going to be looking at a scenario where there was an oil tanker called the Aegean Sea that spilled. There are unfortunately many examples of this, but when you think about how big that is, it's a lot. I mean, it's 84 million milk jugs. That's a lot of oil. So when you think about, and then when that gets into all the cracks and crevices and it gets onto the organisms and things like that, it's really hard to clean off. When the explosion happened in the Gulf, it was years that they were finding balls of oil that were still washing up on shore, even after all of their extremely concentrated efforts to clean it up. They were still finding it for a long time afterwards. For our critters themselves, it not only does it get into their mouths and they ingest it, but it also coats their feathers, which can influence their ability to float. They preen, right? They clean their feathers with their beaks and their mouths, and so not only did they ingest what was actually in the water, but also what's on their body because they're trying to clean it off. And so it was really important that they get out there and try to help out as many organisms as you can. But as you can see, that it's very time consuming. Like taking 2 people to clean one critter, and you think, that probably took them half an hour or so to clean off that one animal. It took a lot of effort to be able to clean up what was going on. The oil in the water also killed off a lot of the benthic, or the bottom dwellers. And so the crab and the fish and the shrimp and the things like that all lived on the bottom, which were the food source for a lot of these organisms, also died. So it really impacted the food supply and the food chain, in addition to industry. When we look about how do we reduce our non-point pollution, so point pollution, gets a lot of press, like when oil spills happen and things like that. There's a lot of press for that because we could kind of have a culprit to point to. It's a little bit more difficult when we talk about that non-point pollution. And so it's more little things that most people wouldn't even know were going on that we're going to reduce that non-point pollution. You can see some examples of what farmers can do. And a lot of it's just trying to keep all that water inside of their fields, and so that none of that goes away. Along the Mississippi River, one of the big industries is pig farming, and pigs make a lot of excrement or poo, and so they have sedimentation ponds where they put all the pig excrement into these big ponds, and then they let it dry out. They let the liquid part of it dry out, and then they will compost it and use it for fertilizer. But when things like Hurricane Katrina happen, and there's a lot of flooding, those sedimentation ponds get flooded out, and now you've contaminated your whole water supply. So just making sure that we're keeping those away from the water supply and from steep slopes and things like that where floods can happen. So there's some laws that are in place. In the United States, we have the Clean Water Act. Really, one of the precipitating events was in one of our big cities back east. A river actually caught fire. I think it was in Chicago. The river actually caught fire because there were so many chemicals in the water that when a fire happened, it was actually like on top of the river, but it was the fumes and stuff from the chemicals that were in the water actually caught fire. And at that point, we were like, okay, we probably should do something about this. And so the Clean Water Act does set standards for what's allowed to be in our water, and then also that you have to have a permit if you're generating any of that kind of pollution, so they know where it's coming from and who to charge, basically, if they're over polluting. We also have the Safe Water Drinking Act that we'll talk about a little bit because we have a little bit stricter regulations on our drinking water. So when we look at other ways to reduce our water pollution, obviously so we talked about where we locate things as far as farmers and things, but it's also about what we do with our water that comes out of our houses. And so when any water that goes down into your pipes is going to go into the water treatment plants here. So we have different ways to treat our sewage. The first one is primary, and this is, I know it's not the pleasant things to talk about, but this is what happens when you flush, essentially, is that the first thing that's going to happen is that it's going to take out all the visible things. So it's going to take out all the chunks and stuff like that. It's going to screen it all out, And then they'll go back in and they'll do a secondary process where they put in bacteria into the water that will actually eat up all of the remaining stuff that's in there. And then when it runs out of things to eat, then it dies. And so then you end up with cleaner water. And then they can go through that third level, which is where they've used like chlorine or something like that to chemically treat it to make sure they've killed off everything else. Another option for cleaning our sewage treatment out is through more natural means and using natural and artificial wetlands. We actually have one of these in Gilbert. It's actually really cool. If you ever have the opportunity to go down and check it out, it's a wetland that's in Gilbert. And so there's birds and things that you wouldn't expect to have in the middle of the desert are down in there, but it is a way that there's different, they section it out. So there's different pond areas basically, and the water gets pumped through the different ponds. And through natural processes, through the plants and the bacteria in the water and things like that, it actually cleans out the water that's in there. And the video clip that's in Canvas talks about the one that's in the Humboldt Bay, which is really pretty neat. They use it instead of a wastewater treatment plant to clean all their water out for people. So this is what I was talking about, is that we have the Clean Water Act. We also have the Safe Water Drinking Act. And so this one says it's actually a bit more strict on what can be in your drinking water. So the Clean Water Act is for all waters, so all surface, ground, and ocean waters. The Safe Water Drinking Act specifically regulates what can be in our drinking water. Unfortunately, most countries in the world don't necessarily have water quality standards. The developed countries do, developing countries not so much, which leads to a lot of health issues in the developing nations, because when they're drinking water that's not clean, it actually impacts pretty much your entire life. So there's quite a few people in the world that are drinking water that doesn't really meet our EPA standards, especially here in the United States. And a lot of this happens because, I mean, probably you've heard about Flint, Michigan by now with the water contaminants that are in their water supply. If you've ever seen the movie Erin Brockovich, that was about clean water as well. Lead pipes being still in use in some places, things like that will still impact whether Americans have access to clean drinking water. So there's a lot of pressure to make sure that we rectify that situation so that everybody in the United States can have access to clean drinking water. There are worldwide organizations that will help to bring either wells or water filters to people in developing nations to help them with their water supplies as well. So what can we do about it? When we look at preventing our groundwater contamination, we want to make sure that we're reducing that non-point pollution. We use those best practices for trying to keep the water that's contaminated out of our surface water and out of our supplies. And when we reduce air pollution, I'm going to skip down just a little bit because we kind of talked about some of these things. But when we reduce air pollution, pretty much everything that goes up comes down. And so if we're putting smoke and things like that up into the air and into the atmosphere by burning things that cause pollution, it's going to come down into our water. 70% of our planet is water, and it's going to hit water at some point in time. So if we reduce our air pollution, we're actually going to increase our water quality as well.